Good morning, everyone. Today I'm going to talk to you about what the journey looks like from moving from data centers to hyperscalers, the challenges that you face in the journey, and how you could leverage hybrid deployment models in overcoming some of these challenges that you face in moving from data centers to hyperscalers. As Dave introduced, I'm Nadeesha. I'm a solutions architect at WSO2. I also head the solution architecture practice for APAC region, and I work with a lot of customers in the APAC region who's struggling to move from data centers to hyperscalers, and we help them to go on a hybrid deployment model to make sure that they get the best of breeds in running things both on-prem and hybrid and on cloud as a hybrid deployment. So I'm sure all of you would have come to a position where whether you discussed or looked at whether you should move to cloud. Obviously, there are many benefits of moving to cloud. I'm sure all of you know it, but I'll just go through them. One of the main advantages of moving to cloud is the maintenance and management convenience. As an organization, you always look to make things easier for your own teams. So that's one benefit that cloud brings to the table. The second and the biggest advantage I would see is time to market. You could build things faster, quickly, and get things onto cloud rather than waiting for months to have hardware provisioned, another 2 weeks, 3 weeks to have the software been installed on those systems and have everything production ready. You can simply go to your cloud account, provision infrastructure, and have it available in minutes. So that's one of the biggest advantages organizations get by going to cloud. Third is the scalability. So you don't have to worry about scalability. You can infinitely scale on cloud. So that's another advantage. And obviously, the availability is also important. You have multi-region deployments to make things available across different regions. Even within the region, you could have availability for your software that you want to run on cloud. And the cost optimization. So rather than having farms of servers that to serve, say, a peak traffic, you have the option of using certain services as a service, or even use it in a more optimized way. Cloud providers also give certain cloud optimization tips that you could use so that you can optimize your cost. And of course, you can use the latest technology. So example would be if you want to run Kubernetes, it's a matter of clicking a few buttons, and then you have a Kubernetes deployment on cloud. If you are to do the same thing on-prem, you would need to have Kubernetes experts. You need to have a host of different skills that is required to build that kind of a deployment on-prem. So those are some of the advantages in moving to cloud. But you also have challenges. One of the main challenges is your own organization's policies that kind of restrict you on putting certain data on cloud. That is especially seen in the APAC region where there are limited amount of data centers. If you take in Asia, you would have probably about 3 or 4 countries that has data centers. So it's a bit challenging for you to put your customer data outside your country. So that becomes one of the key reasons why organizations want to stay on-prem. Secondly, the regulatory restrictions. Governments doesn't want your local data to be outside your country. So that's another key aspect that we see in the APAC region when it comes to cloud adoption. Third is, of course, the architecture limitations. You have old legacy systems that cannot be moved to cloud. So that's another limitation that you have. Fourth is you need to co-locate your services with your backends. Since your backends are running on-prem, it's not easy to lift and shift everything at once. So that kind of hampers the entire movement to cloud. And the fifth point is the time required to move to cloud. And it takes a lot of time to re-architecture things. We were talking about earlier in the keynotes where we shouldn't look at simply lift and shifting things. You should re-architecture as much as possible. So that requires time, and that kind of hampers the movement to cloud. So hybrid deployment models essentially tries to cater these challenges and allowing you to have best of both worlds, to have certain things run on-prem while the others run on cloud. And it's becoming very popular. Part of the deployment, in a hybrid setup, part of the deployment would reside on-prem. The other part will be essentially on cloud. Advantage is you have the advantage of using best of both worlds. You have the flexibility as well. So you could choose to run certain services that needs to scale on cloud, while the things that has customer data can be on-prem, and you could work as a one cohesive system with these components together. You also have the advantage of serving traffic closer to your customers. This applies if you are going to do multi-regional deployment. You could have part of the customer-facing applications on cloud, while the others that does back office work can be on-prem, so that you can stay close to the customer when it comes to certain applications that serve those particular customers. And finally, you could actually comply with the organization's processes in terms of regulations, local regulations in terms of keeping data on-prem, the important data on-prem, while being able to use certain services that are non-critical on cloud. Some of the common patterns that we see when you run hybrid deployments is you have customers who use cloud for external traffic. So you would have, Shastri was talking about partner APIs, public APIs. Those essentially would sit on cloud, while your internal APIs would be served on-prem. So that's a very common pattern that we see. Secondly, the traffic that needs rapid scaling sits on cloud, so that you can use two reasons for it. You can use Kubernetes to kind of scale up those gateways or those backends that needs to serve rapid increases in traffic. And at the same time, it also gives stability for your on-prem systems. So you don't bring those traffic that needs scaling quickly on-prem, and it doesn't impact your day-to-day businesses since it's not served on-prem. Again, the other pattern is low priority traffic is served from cloud, where high priority internal traffic always is served from on-prem. We also see a lot of cases where new projects, if you are doing a new initiative, that most likely goes on cloud, while your existing things still run on-prem. And then for customers who want to use cloud services like Kubernetes, cloud functions, they decide to put them on cloud. And some of them actually use cloud as a DR site. So you would have both cloud and on-prem. Cloud becomes a DR site for your on-prem work. On-prem becomes your DR site for your cloud work. So that's another pattern that we see with our customers. So talking about how WSO2 products are designed to work on a hybrid deployment. From the inception itself, hybrid deployment is something that we've thought through, and the products are built ground up to kind of help or work in a hybrid setup. We are also infrastructure agnostic, so it doesn't really matter where you run our products. It can run on VMs, on Kubernetes. It still works the same way. The product components are decoupled. This is quite important for API manager, where there is multiple components. You have your control plane, your gateway. All of them are decoupled, and they are built to scale independently, and they are also adopting event-driven messaging as much as possible. So whenever the gateway scales, it doesn't have to be directly connected with the control plane. Control plane can sit somewhere else, and they are connected with the event-driven messaging architecture to communicate internally within the product. The product also tolerates network delays. The latest versions of the products are quite well designed to handle these network delays. So if there's delays from gateway to the control plane, the product can tolerate these delays. That allows you to have your part of the deployment on cloud, even on a different region, while the control plane can sit on-prem. There can be network latency and delays, but that doesn't impact the functionality or the experience for the customer when it comes to using the product. And we also have the ability to work across different network boundaries. So I'll talk about the three aspects that we target on. First of all is managing APIs. How do you manage APIs in a hybrid deployment? As I was explaining earlier, in a API, managing API scenario, you would have gateway and control plane separation. So gateway runs separately, control plane runs separately. And you can have the option of deploying the gateway on cloud, while the control plane can be on-prem. And you could also have separate gateways for separate networks. So again, coming back to Shazni's example of private APIs, partner APIs, and public APIs, you could have your partner and public APIs on cloud, while your internal APIs or private APIs can be on-prem. And they are all controlled by a single control plane. You can also co-locate gateways with the backend. You could have certain backend services that may be running as cloud functions, and you can co-locate that, expose them through a cloud gateway that you deploy on cloud, while your on-prem services that runs a legacy system can be running through on-prem gateway. That pattern is also quite common and being used by multiple customers. You can also use services like Kubernetes, services like EKS, AKS to deploy gateways that needs to serve high amount of traffic so that it can also scale with the traffic that comes in. So from a product architecture point of view, this is what it looks like. So you would have your control plane here that basically is essentially the event hub. So you create your APIs, subscriptions, applications on the control plane, and your gateways, wherever they sit, will listen to, will communicate with the control plane or the event hub through a topic. So they will actually listen to the event hub, whether a new API is created, a new subscription is created, and so on. And then when some event happens, it will pull that event and update itself. So that gives the capability for the cloud gateways to be anywhere, or the gateways to be anywhere in that case, even across networks that has huge amount of latency, you still be able to update itself, and it doesn't depend on the event hub. And all the APIs are persisted, stored in one database that's linked to the event hub. One of the cool custom examples that we work with in one of our customer scenarios is a customer who's in the horse racing business. Their primary business is horse racing, which is essentially catered to the older market segment. And they are also venturing into sports betting, mostly football, Premier League, UEFA kind of football betting is their new business. So what they have done is they run a very robust deployment on-prem that serves the on-prem traffic that's predominantly targeting the horse racing business. And the new business, which is the football betting business, is served from cloud. And how they do that is their target market is EU. They work across multiple countries in EU. And they run the football related APIs, football betting related APIs on cloud in Europe. And all the APIs are controlled from a single control plane that runs on-prem. The football betting business is relatively new and also has very high variability in demand. So you would have days where there's extremely high traffic, while the other days you don't have much traffic. And that allows them to scale the deployment of the new business quite fast when it runs on cloud. And it doesn't impact whatever that's going on in the horse racing business that's running on-prem. The deployment looks something like this. You would see let me start from this side. So you would have the control plane that controls everything. And you would have your on-prem cluster of gateways that handle the on-prem traffic. You would have the cloud gateway cluster handling the new business. All are connected to the same control plane. Traffic management is done on both sides. You would have traffic managers sitting on cloud and on-prem, and they are the ones that keep counters in terms of who's calling what APIs and so on. But they sync themselves with each other, and then if a new policy is created or a new subscription tier is created, the traffic managers get updated through the event hub, and then it keeps itself updated with each other. When you look at managing integrations, a similar scenario happens, but from an integration point of view, you essentially have two patterns. You could have a centralized integration pattern where you would run all your workloads on a centralized ESP, or you could have a decentralized pattern where you could run multiple integrations as separate instances in a decentralized manner. Again, the same advantage, you have the option of deploying it in different network segments. You could have one centralized ESB on-prem, while the decentralized microintegrators could run on cloud. And then everything is monitored through a single integration dashboard. So you could see what's happening at a global view across multiple network environments through single dashboard. And you could have the option of directly deploying services and artifacts through a CI/CD pipeline to all these microintegrators through a same CI/CD pipeline. This is what a decentralized microintegrator architecture would look like. You would have your CI/CD pipeline that can take your Carbon applications, Ballerina files through a CI/CD pipeline, deploying it either to the on-prem cluster of microintegrators or to the cloud cluster of microintegrators. And they are all connected to a single integration dashboard so that you can see what's going on. You could see what's deployed on each of these clusters and then have some control in terms of what's running on each of these network environments. If you look at from a centralized microintegrator point of view or centralized integration point of view, it's a more simplified view of things. You would have on-prem microintegrators that runs on-prem, and then there's a cloud microintegrator there. Same CI/CD pipeline could deploy to both at the same time. You could decide to have certain integrations only on-prem, or some can be on cloud, or can be on both environments, depending on your business requirement. And everything can be monitored through a single integration dashboard. Custom example on this scenario is a customer in the amusement park business. They are also a customer who has a lot of legacy infrastructure that are running. They have old systems, legacy backends that runs on legacy technology. And they also have SAP and other proprietary systems. So what we do is we use the on-prem setup to manage all the legacy systems, SAP and legacy integrations. There's a lot of batch jobs that are running, SKU and inventory syncing, that's all done on-prem. They also target the ticketing systems that are on cloud. So we are using the cloud integration setup for the ticketing systems and to integrate with other serverless functions. They run a lot of Azure functions and so on, and that's all integrated through the cloud integration. And then the ticketing system is quite variable in demand as well. So when there's a school holiday, you would see a huge amount of traffic. So we have the capability of horizontally scaling what's running on cloud, while the on-prem is a batch operation that runs on a predefined schedule. And this is what it looks like. As I was explaining, you would have the ticketing system and cloud functions connecting to the microintegrator that's on cloud. And on-prem, you would have the microintegrator that does the batch jobs that runs on a periodic basis. And there's a connection between the on-prem, on cloud microintegrator and the database. And that is managed through a site-to-site VPN or VPN tunnel to connect what's going on cloud to the on-prem database. Thirdly, let me talk about how you manage identities and a hybrid setup. Managing identities also, in a hybrid setup, you are able to manage identities across multiple network environments. You would be able to authenticate users if you're running a regional business, you are able to have multiple identity management systems that manages users on different users who are coming from different regions to access your system. The advantage of this is you are able to manage clients from multiple locations and multiple networks at the same time, and then able to independently scale the authentication process across the different regions and different network environments. And then most importantly, they are used as a failover. So a customer would use the cloud setup as the failover for their on-prem identity and access management. So if a user tries to get themselves authenticated on-prem and it doesn't work, you have the ability to use the cloud setup as the alternative or the DR side so that they get routed to the DR's identity provider and gets authenticated through that. This is what the setup would look like. You would have your external customers getting authenticated from the on-cloud identity server, and then it has its own LDAP that's connected and has its own token database. You would have your internal users getting authenticated through the on-prem identity server, and it has their own token database and Active Directory. Customer example of this is we work with a trading platform that again operates across multiple geo regions, and identity server is deployed across these geo regions. They serve the Asian customers from the on-prem data center so that they are authenticated through that on-prem database. And the Middle Eastern and European customers are served from cloud. And this is what it looks like. You would have your on-prem customers coming in and getting authenticated. On-prem becomes Asia and ANZ users who comes and authenticated from the identity server that's running on-prem. They have two cloud deployments, one in Europe and one in Middle East. Users in Europe will come in and gets authenticated in the identity server running in Europe, and they have its own user store. In the Middle East, the same architecture, you would have users coming in and getting authenticated from the identity server that's running in the Middle East. It also acts as a failover, so in case in case the on-prem region fails, you are able to redirect users from the Asian region to Europe, and they get there's a user store syncing happen independently, and you are able to still log in to your application even if the identity server in one network zone fails entirely. So some of the challenges, so I was talking about some of the advantages that you get by using cloud deployments and doing hybrid deployments. But one of the challenges, or few of the challenges that you face is listed here. One of the key challenges is the network latency, and it's impacting the product performance and functionality. So this has been an issue for us for a couple of years, and then we've re-architected our products to become event-driven as much as possible so that it doesn't impact the product performance and the functionality that we provide. Network restrictions becomes another key issue when you run things hybrid. How do you allow your databases to get connected to the cloud? How do you get your backend systems to get connected to the cloud? All these network restrictions becomes an issue. Shipping updates and patches also becomes an issue because you have to run two update processors, patching processors to servers that are running on two different networks. Running things on cloud also makes you susceptible to have inconsistent deployment models. What that means is you would run VMs, for example, you would run VMs on-prem, while on cloud you may choose to run on Kubernetes. So you have inconsistent deployment models. You may have different technologies to automate those deployments. On-prem can be like something like Puppet or something, while on cloud it can be Helm. So it becomes a bit of a challenge in managing these inconsistent deployment models. And login and correlation of those logs also becomes a challenge if you don't have a tool to manage these logs internally. Overcoming these challenges, one of the key things that you could do is to operate in isolation. So you could essentially have on-prem running separately, cloud running separately, but it becomes a part of an entire, like a holistic deployment. But the users they serve are entirely isolated. That's one way of handling this. Session affinity is another way. You make sure that all the traffic are served from the same network so that there's some session affinity involved. And when possible, to stick to the same deployment model. So if you're doing Kubernetes on cloud, you may also want to use a similar mechanism, Kubernetes type of deployment, either on OpenShift or Rancher on-prem as well, so that there's some consistency in the deployment model across the network environments. And to use log aggregation tools like Elk or Kibana Stack to make sure that you are able to aggregate logs effectively across multiple network environments. So that's another thing that you could do when you do hybrid deployment.